Okay, we have a pitcher's mound on a softball field is 46 feet from home plate. The distance between each base is 60 feet. How far is the mound from first base? So we're going to draw a picture. We've got home plate right here, and then we've got 60 feet to first base. Now, the distance around all the bases is the same. So they call it a diamond, but it's really a square. So it's a square that's rotated. It's not a rhombus. I mean, it is a rhombus because every side is 60 feet, right? So that defines as a rhombus. But the fact that we've got 90-degree angles in there makes it even more special. It's a square. And then we've got the pitcher's mound right here is about, well, it's 46 feet from home plate. So we want to find this red distance right here. Now, some people think that that's a right triangle, but the only thing that we know is that this angle right here was getting cut in half. It's 45 degrees. So I've got side, angle, side. I don't know the measure of the other two angles, quite honestly. Matter of fact, the way I've drawn it, that red segment from pitcher's mound to first base is obviously not cutting first base angle in half. So how do we find that red distance? Let's call that red distance x. So I know I'm going to have x squared, and that's going to equal 46 squared plus 60 squared minus 2 times 46 times 60 times the cosine of the angle across from x. And the angle across from side x is 45 degrees. So it's a cosine. Now it looks weird. It looks like CO5. So let's just make it cosine of 45 degrees. Still looks like a 5. It's weird. Okay, so x is going to equal the square root of all this, right? Because I'll square root both sides, but since x is positive, distance is positive, we're not going to have plus or minus when we square root both sides. I'm going to put this into my calculator, and when I put this into my calculator without hitting the radical, I should get 1812.770568. So if you don't get the answer I'm going to get at the end, you can do baby steps and you can check to see, well, did I get the 1812 when I put all that other stuff into the calculator? And then x is going to approximately be 42.577 feet. I usually, quite honestly, go straight here to my answer. So I square root and I just enter underneath the radical using my calculator the whole darn thing, and I get right to 42.577 without doing too much work. Now here's a try for you. A ship travels 60 miles due east and then adjusts 15 degrees northward. And then after an additional 80 miles, how far is the ship from its point of departure? So I encourage you to press pause right now and try and draw this. Press pause right now, try and draw this, and see if you can set it up. If you're having trouble, go ahead and press play, and that's what I'm going to do first, is I'm going to draw this out. So I've got the ship. It's going to head due east. Then, instead of continuing due east, it's going to shift 15 degrees. Now, that's not 15 degrees, so let's be realistic here. That's not even 15 degrees, but that's about the best I'm going to get. It's going to adjust 15 degrees northward, which makes this big angle 165 degrees. We want to find from the point of departure 60 miles, and then an additional 80 miles. How many miles are we from the point of departure? after that point in time, right? After it's traveled 60 miles and then another 80 miles. So this is side angle side. I need to figure out what X is. So now if that drawing helps you, go ahead and press pause again and see if you can work it out. X is going to equal the square root of 60 squared plus 80 squared minus 2 times 60 times 80 times the cosine of 165 degrees. So X is approximately 138.827 feet. So that's how far the ship is from its point of departure. So those are some examples of using law of cosines. The next video, we're going to talk about area once again. So just like law of sines had a formula where we could use to find the area of an oblique triangle, same thing with law of cosines. We're going to use what's called Heron's formula. So Heron's formula allows us to find the area of a triangle knowing just the 3 side lengths. We don't need to know any angles whatsoever. If you know 3 side lengths of a triangle, you can find the area. It's a pretty cool thing.